Today's topic for the session is probability. What is probability? In general, we call probability as a chance. Probability is said to be a chance of happening and not happening. So what do you mean by happening and not happening? Let's see with one of the small activity, because we see in many international cricket matches there's a tossing of a coin through which they decide on the batting or the bowling. So this has a lot of probability which can be applied for tossing of a coin to decide on the winning side of the country which takes the batting or the bowling initially. We are very enthusiastic to know which country, if India and Pakistan plays the match, we are very enthusiastic to know whether India is batting first or it is bowling first. And that is purely decided on tossing of a coin. Now, what is the rule of tossing of a coin in international cricket matches? Let's see through a coin. Now, I have a coin in which I have heads in one side of the coin, and then on the other side I have tails. Usually this three-headed lion is called heads, and the other side of obviously is called a tail. Now coming to this, the tail and the heads is what is the coin, with heads and tails. Now this once again with tail and once again with heads of this 10 rupee coin which I'm going to show. Now I want to know whether I get heads or tails if I just toss this coin. I say it is heads, and yes, it is heads. It is heads. It is. And then because I got heads, I'm happy that I'm going to choose on whether I'm going to bowl or bat depending on the weather conditions and the pitch conditions. Now this question of whether I'm going to get a head or a tail is the biggest question in mathematics. When I toss, I got a head, but when I toss, I may get a tail. This time I got a tail. This time is a tail. Now I got a head in the previous case and I got a tail in the second case of tossing of a coin, which makes me puzzled or think of on when can I get a tail or when can I get a head is the biggest question which connects probability, indirectly called the chance. So the chance of getting a tail or chance of not getting a tail is how we judge on probability. So to start with, the head and tail we have seen in tossing of a coin. Let's come back with some mathematical understanding. Now in this tossing of a coin, I can either get a head or I can get a tail. So there are 50-50% chances of getting a head or a tail because there are two possibilities. One is the head and one is the tail, out of which there are 50% chances of getting a head and 50% chances of getting a tail. How do you know that there are 50% chances? Is the biggest question here. Because when you toss a coin, there are equally chances of getting a head or a tail out of the 100% of possibility. So this kind of questions are arising due to the probability which we need to estimate through mathematics. So let's see through many further examples on how we can estimate the chances of happening or not happening through probability connected with mathematics. Now let's take one more example to understand probability more better. So for example, I have two possibilities with bag 1 and bag 2. In both of the bags, I have say different colored balls, in which in this bag I have So totally I observe that in this bag there are 1, 2, 3, 4, 5, 6 balls, assuming that these are the balls inside the bag. And in this bag there are 1, 2, 3, 4, 5, 6 balls even in bag 2. But here there are 5 balls which are red in color and 1 ball which is blue in color. But in this case there are 2 balls which are red in color, 2 balls which are blue in color, and 1 ball which is white in color, or 2 balls which are white in color. So if I see the comparison between bag 1 and bag 2, my question is, what is the chance? The question here is, what is the chance of picking up a red ball from each of the bags is the question out here, through which we understand the probability or chance of happening more better. So with the question being, what is the chance of picking up a red ball from each of the bags, we have the bag 1 clearly with 5 red balls and 1 blue ball, and here this bag with 6 balls being 2 with red, 2 with blue, and 2 with white. Now the question being, what is the chance of picking up a red ball from each of the bags? I think this bag has more chances of picking up the red ball because there are 5 red balls and only 1 blue ball. So chances of picking a red ball is more here. And the chances of picking the red ball is not that high because equally all the different balls are of same color. Equal number of balls are of different colors, where 2 red, 2 blue, and 2 white may not be a higher chance of picking up a red ball from the bag. But this bag with 5 red balls, the chances of picking up a red ball is more high in this case and less of in this. This makes us understand that situations differ, then the chances of happening and not happening differ. In the case of bag 1, chances is more of picking a red ball, and in bag 2, chances are less of picking a red ball. Simply because there are more number of red balls in this bag and there are less number of red balls in the bag, is how we understand. So the answer for this question is obviously bag 1. This is the answer. Bag 1 is the answer. So this is how we understand probability in daily life connected with many problems. But what is the exact definition or the exact formula through which we can identify the probability or chance of happening and not happening using the real life situational problems is what we're going to discuss for the session. Probability connected with the formulae. Now let's see the types of probability. Now here we have 2 different types of probability which differs between the experimental probability and the theoretical probability. So let's see each of them, the different types of probability. Experimental and theoretical probabilities. Now, as the names itself define clearly, experimental and theoretical clearly makes us understand that the initial probability, which is called experimental probability, is conducted through an experiment. This is through an experiment. Now, to come with this experiment, I identify that different experiments give different values of probability. Say, for example, one of the French mathematician by name Buffon has tossed the coin 4,440 times. If I toss a coin 4040 times, he could get 2048 heads. Out of this, he got 2048 heads. So this is purely an experimental probability because an experiment was conducted in attempting on tossing a coin 4040 times. And then he could get totally on the whole when counted 2048 heads and the rest were all tails. So he calculated on the chances of getting the heads through this experiment counting up to 4040 times of tossing of a coin. So clearly he just did, he got the probability as simply 4040 times which he has attempted, out of which he got 2048 heads. When divided, it gave the value approximately the value as 0.507. So this was the value as obtained for an experiment which had 4040 times of tossing of a coin. Now what happens if this number is increased? If I increase up to 10,000 times of tossing of a coin, then definitely the number of heads also change the outcome which we cannot predict. Then when this was divided with this, then this divided with this, then approximately gives the value 0.5 etc. but it may not give exactly the value. So such kind of experiments through which we identify the percentage of chances of happening and not happening is called experimental probability. The process of experimenting by tossing number of times and then finding each of the results is called experimental probability. Now what is theoretical probability? Theoretical probability is not done through an experiment of so many times of tossing a coin, but we assume that when I toss a coin, the possibility is, when tossing a coin, the possibility is either getting a head or a tail, where two sides of a coin will give me one head out of two sides and one tail out of two sides. So these are the chances of happening, getting a head or a tail, is how we understand the theoretical probability. The possibility of getting a head is 0.5 because one head out of one head and tail, which is 2, and one tail out of this with this, so that I get one head out of head and tail is two sides, which gives me 2, and one head is one of the head which are right here. Similarly, one tail out of one head and one tail is what I get for this. So my experimental probability of the same coin when it is tossed 4040 times gave me 2048 heads, makes me understand that the probability is 0.507 through the experimental probability, and the theoretical probability makes us understand that one head out of two possibilities and one tail out of two possibilities gives me 0.5, which is based on the theoretical probability. This is how we differentiate between the theoretical and the experimental probability, the types of probabilities which we have discussed out here. So let's see the theoretical probability in brief, because most of the problems in the session are related to theoretical probability, and hence finding the chance of happening and not happening through theoretical probability. So theoretical probability, as we have defined in the previous session, has its own definition in the formula which we're going to take here. So let me take first initially the event E which I'm going to conduct. Let E be the event. Now the event depends on the situation of the problem. Tossing of a coin is one of the event, or playing of a game on the dice, throwing of a dice is one of the event, or picking up a ball from the bag is also one of the event. So different problems have different situations which hence define the events. So in general, let E be the event which I'm going to find. Then in this case, my probability of happening of an event E is given by So probability of happening of an event E can be anything, is given by the symbol P of E, generally denoted as probability of happening of an event E, is given by the formula number of trials in which the event happens, number of trials in which the event happen by total number of trials. So this is how we define the probability of an event in mathematical formulae. So probability of an event E is number of trials in which the event happened by total number of trials. So let's see how we can use this formula for an example problem. Say tossing of a coin, as I have taken. For tossing of a coin, I got the total number of events. In the event of tossing of a coin, the probability of getting a head, if that is the event, then that is total number of trials is either getting a head or a tail, being two possibilities, and number of trials in which the event happened or getting of a head is one possibility. Therefore, for this, using the formula, I get probability of head, getting a head is 1/2, is how we understand. So let's see more examples to understand this formula more better. To start with, one of the example problem connecting with the formula. Now let's come with the more modified definition of probability as dedicated to one of the mathematician called Simon Laplace. So there are many mathematicians who have come up with different modifications on definition of probability, but the most accurate definition we are going to take now is the probability of occurring of an event E is given by, denoted with P of E, is number of outcomes favorable to event E by total number of possible outcomes. Is how we come out with the most modified definition of probability, the theoretical probability of happening of an event E or occurring of an event E, given by number of outcomes favorable to event E by total number of possible outcomes. Let's see an example problem connected with understanding the probability through the mathematical formula. So what is sample space? Sample space is very important before we start with the problems of probability using the mathematical formula as defined in the recent session. Now before we start with the problems, sample space has its own definition. What is sample space? The definition says set of all possible outcomes of an event E is called the sample space. Say for example, we all know what a dice is. Usually we use this dice in playing a game where you have one dot and then we have two dots and then we have three dots or 4, 5, 6, etc. So in this dice, I have totally set of all possible outcomes when I throw a die is I may get a 1 on the top, a 2 on the top, a 3 on the top, a 4, 5, 6, anything on the top. But I cannot get a 7 at the most on the top. Therefore, the set of all possible outcomes of the event E, here being throwing of a dice while playing a game, is the event E here. Let's see what are the possible outcomes. The sample space, denoted by generally S, for this particular problem is nothing but the first possibility is I may get a 1, and then I may get a 2, 3, 4, 5 or a 6 when I throw a die. So when I throw a die, sample space is 1 to 6. So here this is throwing of a dice. Say I take one more example, tossing of a coin, which we have done. So when I take a coin, and this coin, when I toss it, I have heads, and then the other side we have tails. Therefore, when I toss this, the event here is tossing of a coin. Therefore, my sample space is either getting a head or a tail, because the top can be either head or tail is what is the sample space here. In this problem, the sample space is this. Is how we understand the sample space is the set of all possible outcomes of an event A. For dice being the possible outcomes is 1 to 6, and for a coin being the possible outcomes are either head or a tail. So using the formula of probability of E, of event E, let's see some of the problems. But before that, the probability of occurring of an event E is given by number of events favorable to event E by total number of outcomes, which is sample space. Therefore, this is the formula of the probability of event E is N of E by N of S is what we use to see how we can use the probability. Say, for example, the question is, what is the percentage of chances of getting a 6 on the top when a dice is rolled? So this is the question which we have. Now we know that we have already seen a dice which is rolled or thrown in the game. Then in that case, we see that we may get a 1, a 2, or a 3, 4, 5, or a 6 on the top. So the question here exclusively is about finding the percentage of chances of getting a 6 on the top when a dice is rolled. Now the word chance does immediately make us understand that it is the probability which we need to find, because probability is the chance of happening and not happening. So with the question on finding the percentage of chances of getting a 6 on the top when a dice is rolled, let me take a dice on which I need to get a 6 on the top. So I need to get is how I have the dice on which I need to get a 6 on the top. Therefore, connecting this, my event E here is very important to be identified. The first thing I need to do is identify the event E in the given problem. So for this given problem, my event E is rolling of a dice, because dice is rolled, the event is rolling of a dice in this case. Now with this, I clearly have getting of 6 is the number of events which are favorable to event E, because my target is to get a 6 on the top. That is, my number of targets are 1, that is 6. Therefore, N of E is 1. Number of events, outcomes favorable to the event E is the outcome 6, which is only 1. Therefore, N of E is 1. Now, total number of outcomes, which is the sample space S, because we know that the sample space for this is clearly 1, 2, 3, 4, 5 and 6. So therefore my sample space being 1 to 6 clearly has 1, 2, 3, 4, 5, 6. Total number of outcomes is 6. Each of the phase, the top can be either 1 to 6. Therefore my n of s is 6 is how I understand. Now n of e is 1 and n of s is 6. Using the formula, I have my n of p. P of e is n of e by n of s, which gives me n of e is clearly 1 over 6. Therefore, the probability of getting a 6 on the top is 1 over 6 is what I get. That is, the probability of getting a 6 on the top is 1 over 6. But the question is about percentage of probability or percentage of chances of getting a 6. Therefore, percentage of chances of getting a 6 on the top when a dice is rolled is simply P of E times 100. The percentage is calculated by multiplying the probability with 100. Probability times 100 gives us the percentage of chances. Therefore, using this formula of P of E times 100 for finding the percentage of chances of getting a 6 on the top when a dice is rolled, I simply get P of E times 100, where P of E is 1 over 6. Therefore, in place of P of E, I substitute 1 over 6. That is 100 by 6, which is approximately 6 ones 6, 40, 6 6, 36.66, etc., which is approximately 16.7%. So I understand that there are only 16% or 17% chances or 16.7% chances of getting a 6 on the top when a dice is rolled, not a better chance. 16% is a very less chances of getting a success out of when a dice is rolled, is how I understand with the least of the 16%. So let's see how I can compare the chances with the same example as I considered with a bag containing the different colored balls. So let's recap with the previously done problem and then identify on how we can compare the two chances or the two probabilities. Say for example, I take the two examples, reconsider the two examples as I have taken here with the bag, one which contains 6 balls, and this bag 2 also which contains 6 balls, where here there are 1 blue ball and 5 red balls, and in this case 2 blue, 2 red and 2 white is what we have taken in the previous case, this being bag 1 and this being bag 2. Now in this, let's compare the two chances where is the better chance of picking a red ball. So if I wanted to find the probability of picking a red ball, where the event in this case is picking up a red ball, picking up a red ball is the event out here, then we see that the event of picking the red ball is n of e, that is the number of outcomes I can get out of the red balls is that I can pick 5 different red balls and the total number of outcomes are 6, as clearly seen here. Now in this case, let me say for this it is event E1 for bag 1 and this is for bag 2. Then here the total number of outcomes of picking the red ball is that I can pick 2 red balls out of the total number of balls, which is 6. is what I get further as 1 by 3. Now let's see the percentage of chances. Now percentage of chances is P of E times 100, as we have already seen. So this multiplied with 100 will give me 2 3s and 2 5s. So this is 5 5s, 25 by 3, that is 3 8s, 24, and 10, 3 3s, 0.3% is what I get here approximately. So here the percentage of chances is 83.3% of picking a red ball. Let's see how much is the percentage of chances, how much are the percentage of chances of picking a red ball from the back 2. So in this case, my percentage of chances of picking the red ball is 1 over 3 times 100, because 1 over 3 is the probability as obtained. I get this to be 33.3%. Now where do you think there is a higher chance of picking a red ball? The percentage of picking is just 33% approximately, and the percentage is 83%. It is a good percent to pick the red ball, is how we understand in comparison of chances. So picking up a red ball which contains 5 red balls and 1 blue ball in the bag is more chances are more higher than picking a red ball from a bag containing 2 blue, 2 red and 2 white balls, in comparison of estimating the percentage of chances of 2 different conditions or situations. An example problem.